So what we're going to work on today is, like I said, it's the exact opposite of what we did on Friday. So on Friday, we looked at the distributive property, which is what you just practiced on Y14, where you're taking a number, could be a letter, we haven't had that, but where you're taking a number on the outside of, bless you, a parenthesis and multiplying it by everything inside. So today what we're going to look at is the exact opposite of that. Factoring out a number from an expression and then writing it as a distributive property. Okay, so way back when we did fractions, we learned LCM, least common multiple, and GCF, greatest common factor. Okay, you are going to have to use greatest common factor today when we're doing factoring expressions. All right, so just like before, I'm going to give you the definition. I will read through it once, then I'll break it up. So you could possibly just write as I'm reading it. But I do need all computers closed for now, please. All the way. And music off, so we're listening. Okay, so factoring an expression. Factoring the expression is when numeric or algebraic expressions are written as a product of their factors. Now, again, I'll break that up in a second. There are a lot of big math terms in this, and we're going to talk about those, but let's write it for now. So, factoring the expression is when numeric or algebraic, big word, it's algebra with an IC, algebraic expressions are written as a product of their factors. Okay, so again, one time just threw it off. Factoring the expression is when numeric or algebraic expressions are written as products of their factors. So I want to talk about a few of these words first. Okay. Numeric. What are we talking about? What's the simple math word that we're used to hearing instead of numeric? It's the beginning of the word, kind of like the root of the word. If we're talking about numeric, what are we talking about?
You need to do unblock.
Already done. Haley, numbers. Okay. Algebraic. If something's written algebraically, what does it usually include? That's not numbers, that's numeric. Algebraic would include what? Mateo? It'll have letters in it. Okay, so that's numeric and algebraic. Then we have this word again, product. The product is the answer to what kind of a math question? Only 4 choices. Mason? Multiplication. Okay, so what we're going to end up writing is a multiplication problem. It will end up looking like the distributive property, using numbers, numeric, or algebraically with letters. Okay, so we've got to get used to seeing these bigger math words that you've used other words that mean the same thing, but now we're moving on to bigger and fancier things. All right, so the steps to factoring an expression. The very first thing you have to do is find the greatest common factor for the numbers. Okay, if you know what GCF means, you don't need to write out greatest common factor. But you're going to find the GCF, or the greatest common factor, for the numbers. And everyone should be writing this down. Then, after you find the greatest common factor, you are going to factor out the GCF. My other job is GFS. That's where we get all our food. GCF. Factor out the GCF from all the numbers. Too many acronyms. And this will make sense when we do examples. And then your final answer will be written like the distributive property. So the final thing is, the final answer will be written like the distributive property. So again, this is the exact opposite of what we did on Friday. Friday, you distributed it out. Today, you're going to factor it back. Justin. Say what? Read number 1 again. Find the GCF for the numbers. Okay, and then we're going to do 4 examples, 2 that are numeric examples and 2 that are algebraic. Anyone still need this? Because I'll have to cover it up. Okay. It's right there. The very top, factor the expression. We're just writing all of this, yes. But I'm going to cover it up in just a minute so we can do our examples, and then I can uncover it when we're done with our examples. Okay? All right, if you're not done, I'll uncover it in a second. Give yourself some space to do the examples. So like I said, we're going to do 4 different examples. 2 that are just numeric examples and 2 that have variables in them. So it is going to be super important, as if it wasn't before, but that you read directions, okay? Because you will get a question that looks like this. And they are not looking for 78. Okay? The directions will say something like factor the expression, factor each expression, write it as distributive property, those types of things. Okay? They are not looking for you to add 54 and 24. All right? So, like the steps that we wrote, the first thing you have to do is find the greatest common factor for 54 and 24. Now, back when we did fractions, we learned greatest common factor, least common multiple. There are 2 ways to find both of these things. Okay? I honestly feel the easiest way and the way to make the least amount of mistakes is to use, excuse me, prime factorization and factor trees. Okay. Sometimes that takes up more space, but it's quicker to do. Okay. So I'm going to go over that way first, and hopefully it'll turn on some light bulbs and we'll remember. So when you're doing prime factorization, this was the factor trees that we did. Most numbers can start different ways. Okay. So I always just use the first thing that comes to my mind. 54. I immediately think of 9 times 6. Okay. There's other options, but I just use what comes first to my mind. Then we have to keep breaking these numbers up until we have all prime numbers, usually 2, 3, 5, 7, 11. That's usually what you will end up with. Okay. 9 would be 3 and 3. 6 would be 2 and 3. Then I have to do 24. 2 and 12 comes to my mind first. You could use 8 and 3. You could use 6 and 4. You still get to the same answer in the end. Typically, when they're even numbers, I a lot of times just use 2 because I know 2 goes into it. So 2 is done. 4 and 3, 2 and 2. Okay. Factor trees are pretty quick to do. Then you have to remember, now what do I do with that to find my greatest common factor? So that's where we list the prime factorization. So 54 would be 2, 3, 3, and 3. 24 was 2, 2, 2, and 3. All right, so what? You have to remember what to do. Greatest common factor. You're looking for the numbers that show up in both lists. There's 1, 2 in both lists. There is 1, 3 in both lists. So the greatest common factor for 54 and 24 would be 6. I know it seems like a lot of work, but typically we know our factors of like 54 and 24, the small ones. Okay. The other way to do this, and you are more than welcome to do it this way, and this would have been the way that you always did it in elementary school because they weren't teaching you factor trees in 3rd and 4th grade. So the way that you are probably used to finding greatest common factor, again, I usually make mistakes when I do it this way. That's why I like using factor trees. You have to think of all the numbers you can multiply to get 54 and 24. Okay, and I usually have to use a calculator. So obviously 1 and 54. And I separate them apart, so when I meet in the middle, I should be done. 2 and I believe 27. 3 goes into it, but this is the one I always forget. I think 18. Yes. 4, I don't believe so, but I can always use a calculator and check. Nope, 5 does not. 6, yes. 6 and 9. Okay, so that's all my factors for 54. Then I need to come up with all my factors for 24. So 1 and 24, 2 and 12, 3 goes into it 8 times, 4 and 6. Okay, this method works. I usually end up forgetting one of them. The biggest number in both lists is 6. That's your GCF. So either method works, and you can use whatever you're most comfortable with. I usually find I make a mistake using this method, but if it works for you, use it. Okay. All right. So now what do we do? That was just step 1, finding the GCF. So now what you have to do is factor out the greatest common factors. So this is going to look like distributed property when we're done. My greatest common factor is now on the outside of my parentheses. Whatever the greatest common factor was, goes outside the parentheses. This is addition, so that stays what it was. Okay. Now you have to know your math facts. 6 times what would give us 54? Jordan? to wait. Your hair looks good, by the way. You're welcome. 6 times what gives us 54? Mateo? 9. That goes first. Stays addition. 6 times what would give us the 24 that we need? Diana? 4. And that's it. You're factoring out the greatest common factor. You could always use a calculator. Take 54 divided by 6. You'll know it's 9. Take 24 divided by 6. You'll know it's 4. Now, here's the nice thing about factoring out an expression. You can always check to make sure you're right. Just do the distributive property in your head. If I took 6 times 9, that should give me my first number. If I take 6 times 4, that should give me my second number. If it didn't, you're wrong. If it did, then you're right. You should always know if when you factor something out, if you're right, by doing distributive property and seeing if you get your answer. Okay? All right. Another example with just numbers. $63. Just kidding. I'm going to do it different. 81 minus 63. Okay? They don't want an answer of whatever it is. I don't know, 13, something like that. They want you to factor it out. So we have to find the greatest common factor for 81 and 63. Some of you may be able to look and know right off the bat what this one is, just because you know your math facts, okay? But you can always do it with factor trees. 81, I immediately think of 9 and 9, and then those are 3 and 3. 63, I know 3 will go into that, so 3 and 21, 3 and 7. If you know your math facts, factor trees are very quick to make. Okay? So my prime factorization for 81 is 4 3s. My prime factorization for 21 is 2 3s and a 7. Common factors. So my greatest common factor would be 9. Okay? Or again, like I said, you can list the factors for 81 and 63. Okay? We'll see if I can do that. Obviously, 1 and 81. It's not even, so 2 doesn't go into it. 3 will, but I honestly don't know how many times. 81 divided by 3, 27. I don't think 4 will. Nope. 5 will not. 6 shouldn't. Nope. I think 7 is going to be it. 81. 8 won't. Nope. So 9. 9 times 9. 63. 1 and 63. 2 will not. 3 will. 21 times. I don't think 4 will. No. 5 will not. 6 will not. 7 and 9. So my greatest common factor is still 9, as long as you list all the factors. If you miss a factor, you might mess up your greatest common factor. So again, factor trees are usually the quickest. Okay? So now what? We have to use that greatest common factor as our number that's outside the parentheses. So we're going to have 9, and this one was subtraction. So now you're just factoring out the 9. 9 times what gives us 81? 9. And 9 times what gives us 63? 7. I always have to imagine my fingers. I was glad someone taught me that trick with the 9s. Makes it so much easier. Now you can check yourself. You should never miss these. Do distributive property. 9 times 9 gives me what I need. 9 times 7 gives me what I need. Okay? Questions on it numerically. Algebraically just changes slightly. Okay, so let's look at two that are algebraically. Um, 11x minus 55. So again, for now, you can ignore the variable. Okay, we're finding the greatest common factor for 11 and 55. Now, some of you that know your math facts well enough, anyone know what the greatest common factor is for 11 and 55? Which is the same for 11 and 99, which is the same for 11 and 66, and 11 and 33, and 11 and 22, because of something that's common. Natalia? Nope, too big. You're on the right track. Justin? It would be 11. Anytime you have 11 in a double number, 11 is going to be the greatest common factor. Okay, but here's why. 11 is prime, so there's nothing to figure out with that. If I did a factor tree for 55, it's pretty simple. Just 5 and 11. So I would have 5 times 11. Common in both rows is 11. So my greatest common factor is 11. If I wanted to list the factors, which for 11 doesn't take too long because it's just 1 times 11. 55 isn't too bad. It's 1 and 55. 5 and 11. Greatest common factor is 11. Okay? So nothing has changed so far. Greatest common factor goes on the outside. This is subtraction. Okay? Here's what's slightly different. You have a variable in there. And when we have a letter show up, we all of a sudden think we don't know how to do math. And that is incorrect. Okay? You just have something new that we're working with. We may get this wrong the first time we answer, and that's fine. 11 times what would give us 11x? 11 times what would give us 11x? Haley? Just x. Yes. A lot of times kids will want to put a 1 in front of it. If you only have one of the variable, x, s, r, z, whatever it is, you do not need to put a 1 in front of it. It would just be x. 11 times what gives us our 55? Jordan? 5. That's your answer. Again, you can check yourself mentally without having to write anything down. 11 times x would give us 11x. 11 times 5 would give us 55. So you have to be right. And our last example. Another one algebraically. Let's do 77x plus 21. So again, whether it's algebraic or numeric, first thing you have to do is find your greatest common factor for the two numbers, 77 and 21. Okay. Seven and 11, those are both prime. 7 times 3, those are both prime. So those were easy. We have 7 and 11. We have 3 and 7. Biggest number common in both lists would be 7. Okay. Or you could list the factors of 77 and list the factors of 21, and you'll still get 7 as your greatest common factor. So I'm going to set up the template for what this is, and I want you to see if you can figure it out. Greatest common factor comes in the outside. It's addition. So figure out what you need on the inside to get 77x and to get 21 when you're multiplying by 7. Come up with something. If you're using a pencil, you can erase it if you're wrong. What would go on the inside? Who thinks they have what we need on the inside? Ayana? Don't forget your X, okay? Other than that, perfect. If there's a variable, always have it. Don't leave it off because it would end up being wrong. So again, check yourself. 7 times 11x would be 77x. 7 times 3 would be 21, and we state addition. So that is your answer. Okay? Exact opposite from Friday. Questions? Okay, then Y17 is what you're working on for today's assignment. That is what I will be looking at for your grade for today's assignment, Y17. So we're not working on Y14 right now. We're working on Y17. You might need to use your notebook to write down stuff to find greatest common factors if your screen isn't big enough for you to find GCF. Hopefully Thursday we'll review our Unit 8, dealing with distributive property, commutative associative identity property, factoring out, and then tomorrow and we'll be working on evaluating expressions to hopefully Friday take our test. If I need to bump it back a day, I will. But right now we're looking at Thursday to review, Friday to test. Okay?